you are eating something you would normally never put in your mouth. It has no sweetness, no smell, no obvious nutritional value. It is simply dirt, yet thousands of years ago, humans sometimes deliberately consumed earth. Not accidentally, not because they had nothing else to eat. In some prehistoric contexts, mineral-rich soils and clays appear to have been collected, processed, and consumed. To you, that sounds completely irrational. But the strange part is that eating dirt can sometimes make biological sense. Your body needs minerals, sodium, calcium, iron, magnesium, and in certain environments, those minerals are difficult to obtain from ordinary food. So prehistoric humans may have discovered that the ground beneath their feet could contain something their bodies needed. But minerals were only part of the story. Some soils could also bind harmful substances inside the digestive system. That means the same material that looked completely useless could potentially protect you from something poisonous. And this behavior is far older than agriculture. It may reach deep into the hunter-gatherer past. One important clue comes from archaeological sites where humans repeatedly processed unusual mineral materials. At Ohalo, on the shores of the Sea of Galilee in modern Israel, people lived around 23,000 years ago. The site preserves an extraordinary snapshot of hunter-gatherer life during the Ice Age. Researchers discovered remains of wild plants, fish, animals, hearths, and grinding tools. The evidence shows that these people were extremely knowledgeable about their environment. They didn't simply eat whatever they found. They selected particular plants. They processed seeds. They collected different materials for specific purposes. And this raises an important question. If prehistoric humans could identify useful plants and animals so precisely, could they also recognize useful minerals? The answer may be yes. Across human societies, the deliberate consumption of soil is known as geophagy. It has been documented among numerous traditional communities around the world. But modern observations cannot automatically prove that prehistoric humans behaved in exactly the same way. Archaeologists need physical evidence, and one of the strongest clues comes from microscopic mineral traces. Certain archaeological deposits contain unusual concentrations of clay and other minerals in places associated with human activity. When these materials appear repeatedly, researchers can begin asking whether they were deliberately collected. But why would you eat clay? One possibility is mineral supplementation. Your body requires minerals to function. Iron helps transport oxygen through your blood. Calcium supports bones and muscles. Magnesium participates in hundreds of biochemical reactions. Sodium helps regulate fluid balance and nerve activity. If your diet is dominated by wild plants and lean meat, mineral availability can change dramatically depending on season and location. A patch of mineral-rich earth could therefore become a useful resource. But there is another possibility: protection. Some clays have an unusual chemical property. They can bind certain toxins. Imagine eating a poisonous plant. The plant contains compounds that can irritate your digestive system or interfere with normal biological processes. Certain clay minerals can attach to molecules inside the gut. They may reduce how much of a harmful compound your body absorbs. This phenomenon has been studied extensively in animals. Parrots and other birds have been observed consuming clay after eating foods containing potentially harmful substances. Some mammals also deliberately consume mineral-rich earth. The behavior is not necessarily random. It can occur after exposure to particular foods. That suggests animals may sometimes use soil as a form of self-protection. And humans may have inherited some of the same behavior. But prehistoric humans faced another problem. Food was seasonal. A plant that was safe in one location might be toxic in another. A wild root could contain defensive chemicals. A mushroom could be deadly. A seed might require processing before it became safe to eat. Without chemistry textbooks, your ancestors had to learn these rules through observation. Some knowledge came from generations of experience. Some probably came from painful mistakes. And some may have come from watching animals. A hunter-gatherer watching an animal repeatedly visit a particular patch of earth could notice something. The animal wasn't eating grass. It wasn't drinking water. It was eating the soil itself. That observation could have been useful because the prehistoric landscape was not simply a source of food. It was a giant chemical environment. Rocks contained minerals. Plants contained toxins. Water contained salts. Soil contained compounds that could either help or harm you. Survival depended on learning which was which. But there is an even stranger possibility. Ancient humans may not have eaten dirt because they were hungry. They may have eaten it because it made certain foods safer. And that changes the question completely. Instead of asking, why would humans eat dirt? You have to ask, What did the dirt allow them to eat? Because once you look at geophagy this way, a handful of soil stops looking like useless earth. It starts looking like a primitive survival technology. And the archaeological evidence suggests that humans may have been using that technology long before anyone could explain the chemistry behind it. One of the most interesting examples comes from Central Africa. Among several traditional communities, people have historically consumed specific types of clay during pregnancy, illness, or periods of food stress. The important detail is that they don't eat random soil. They select particular deposits. The texture matters, the color matters, the mineral composition matters, and the location matters. That suggests the behavior can involve learned knowledge rather than simple hunger. Anthropologist Johns Hopkins and other researchers have studied geophagy as a potential source of minerals and protection against dietary toxins. But there is an important limitation. Modern human behavior cannot be directly projected backward 20,000 or 30,000 years. Your ancestors were not necessarily following the same practices as every community observed today. Archaeologists therefore look for independent evidence. One particularly interesting source is ancient human dental calculus. Dental calculus is hardened plaque. Once it forms, it can preserve microscopic particles for thousands of years. Researchers can sometimes identify plant fragments, starch grains, minerals, and other environmental particles trapped inside it. That means your teeth can preserve a microscopic record of what entered your mouth. And sometimes, that record includes things that were never meant to be food. Mineral particles can become trapped in dental calculus through normal environmental exposure. People handle soil. They process plants. They grind minerals. They live around dusty environments. So finding earth particles alone doesn't prove someone deliberately ate dirt. Researchers need patterns, repeated mineral signatures, unusual concentrations, specific geological sources, and evidence that the material was intentionally collected or processed. This distinction matters because prehistoric archaeology is full of misleading clues. A pile of clay could be a cooking material. A mineral deposit could have been used to make pigments. A dusty grinding stone could have processed plants. Not everything ancient is evidence of eating, but when multiple lines of evidence point in the same direction, the possibility becomes much stronger. And there is another reason clay could have been useful: detoxification. Some wild plants defend themselves chemically. They produce compounds that discourage animals from eating them. Before agriculture, humans depended heavily on wild plants. That meant your ancestors encountered thousands of chemical defenses. Some were harmless. Some caused stomach problems. Others could be dangerous. Processing could reduce these toxins. Cooking could destroy certain compounds. Soaking could remove others. Fermentation could transform food chemically. And mineral-rich earth may have provided another layer of protection. Certain clays can bind alkaloids and other organic molecules. The effect depends heavily on the specific clay and toxin involved. This is why scientists cannot simply say, eating dirt prevents poisoning. It doesn't. Some soils contain dangerous bacteria, parasites, heavy metals, or other contaminants. But particular mineral materials can have useful chemical properties. That difference is crucial. Prehistoric humans weren't necessarily eating ordinary dirt from the ground. They may have been selecting specific geological materials. In other words, they were choosing chemistry without knowing the word chemistry. And this ability to recognize useful substances may have been part of a much larger survival skill. Think about the prehistoric landscape. A hunter sees animal tracks. A gatherer recognizes an edible root. A child learns which berries are safe. Someone remembers where clean water appears after rain. And another person remembers where a particular type of clay can be found. None of this knowledge exists in writing. It lives inside memory. It passes through observation. And eventually it becomes culture. That may explain why geophagy appears repeatedly across human history. The behavior doesn't need to be instinctive. It can be learned. A child watches an adult collect a particular clay. They learn where it comes from. They learn how much to consume. They learn when it is useful. And decades later, they teach someone else. The information survives even though the original discovery may have happened thousands of years earlier. But there is still a major mystery. If eating mineral-rich earth could sometimes provide benefits, why didn't humans simply get those minerals from food? The answer may lie in the environments they lived in. Some landscapes are extremely poor in certain minerals. Others contain plants that interfere with mineral absorption. For example, Compounds such as phytates can bind minerals in food and reduce their availability to the body. A person can consume a mineral without absorbing all of it. So the nutritional value of a food isn't determined only by what it contains. It also depends on what your body can actually use. This becomes especially important during pregnancy. A developing fetus requires minerals. The mother's body has to supply them. In many modern populations, mineral deficiencies can be treated with carefully measured supplements. Prehistoric humans had no tablets. They had landscapes, plants, animals, water, and mineral deposits. If a particular clay contained useful minerals, consuming small amounts could potentially supplement the diet. But that still doesn't explain everything, because some researchers believe geophagy may have had another function. Protection during pregnancy. Certain clays may bind plant toxins and reduce their absorption. That could be especially valuable when a pregnant woman experiences changes in taste and food preferences. But the evidence remains incomplete, and that uncertainty is important. The prehistoric world does not give you neat medical records. It gives you fragments, a mineral deposit, a grinding stone, a microscopic particle, a preserved tooth, a chemical signature. You have to reconstruct the behavior from those fragments. And sometimes the simplest explanation is not hunger. It is knowledge. There is one final clue that makes the story even more interesting. Your ancestors lived in a world where almost everything had consequences. A plant could feed you. The same plant could poison you. A mineral could be useful. Another mineral could damage your body. Water could save you. Contaminated water could kill you. The difference was knowledge, and that knowledge accumulated slowly. Imagine a group living thousands of years ago. One person discovers a mineral deposit. The clay has a particular color. It has a distinctive texture. Animals visit the same location. Perhaps someone notices that eating a small amount does not make them sick. Maybe it reduces stomach discomfort. Maybe it helps after eating a bitter plant. Maybe it provides a mineral their normal diet lacks. The original reason may be forgotten, but the behavior remains. Generation after generation, someone remembers that this particular earth is useful. That is how prehistoric survival often worked. You didn't need to understand why something worked. You needed to remember that it worked. This is one of the most important differences between modern science and prehistoric knowledge. Modern science asks for mechanisms. Ancient knowledge often began with observation. You don't need to know what an alkaloid is to learn that a particular plant makes you sick. You don't need to understand adsorption to discover that a certain clay helps after eating something bitter. You don't need to know mineral chemistry to recognize that a particular deposit is valuable. Experience can come before explanation, and prehistoric humans had an enormous amount of experience. For more than 300,000 years, our species has been experimenting with the natural world. Neanderthals were doing it too. They used fire. They processed plants. They made adhesives. They selected different stones for different tools. They exploited animal fat. They knew where resources were located. Their environment was not something they simply lived inside. It was something they constantly studied. So when you find evidence that humans consumed mineral-rich earth, it shouldn't automatically be interpreted as desperation. Sometimes it may have been. During famine, humans can consume almost anything, but deliberate selection of specific clays suggests something more complicated. It suggests knowledge. Knowledge about the landscape, knowledge about the body, knowledge about food, and knowledge about danger. That is what makes the behavior so fascinating. The dirt itself wasn't necessarily the food. It may have been the tool. A tool made of minerals rather than stone. A tool that entered the body instead of being held in the hand. A tool that could potentially reduce exposure to toxins, supplement minerals, or alter how certain foods affected digestion. But there is a limit to what the evidence can tell you. There is no prehistoric medical textbook explaining why someone consumed a particular clay. There is no surviving voice saying, "This earth protects you from this plant." Instead, researchers work with fragments, archaeological deposits, dental calculus, mineral chemistry, ethnographic comparisons, animal behavior, and experimental studies. Together, these clues can reveal possibilities. They cannot turn every ancient behavior into certainty. And that distinction matters, because prehistoric humans were neither primitive versions of modern people, nor perfectly adapted survival machines. They were experimenting, learning, making mistakes, remembering what worked, and passing that information forward. Sometimes, the solution to a problem was hidden inside an animal, sometimes inside a plant, sometimes inside a fire, and sometimes it was beneath their feet. The strange part is that you still do something similar today. You rely on substances every day whose chemistry you may not fully understand. You take medicine without knowing every molecular interaction. You eat fermented food without thinking about the microorganisms transforming it. You drink mineral water because someone tells you it is good for you. The difference is that modern humans can explain the chemistry. Your ancestors had to discover it first. They had no laboratories, no nutrition labels, no periodic table, no toxicology reports. They had observation, memory, and thousands of generations of accumulated experience. So the next time you look at a handful of dirt and see something completely useless, remember that your ancestors may have seen something very different. Not just soil, not just dust, but minerals, protection, information, and perhaps, under the right circumstances, a survival tool hiding in plain sight. If you want to uncover more of the strange survival strategies that shaped ancient humans, subscribe to the channel, because the deeper you look into our past, the more ordinary things begin to look surprisingly important.